Writing and balancing chemical equation. We've learned how to write chemical formulas. Now we have to write the chemical equations, which represent a chemical reaction. So what is the difference between chemical reaction and chemical equation? Well, basically they're the same thing. The chemical reaction is the actual process, and chemical equation is the way that we are representing it. We are using the formulas, the chemical formula to write chemical equation. Now you have to be careful. In mathematics we use formula and equation interchangeably, but in chemistry they are different. Chemical formula, for example, for water is H2O. That's the chemical formula. But chemical equation is showing a whole chemical reaction. We're going to learn how to write chemical equations and how to balance them. Okay, so how do we write the chemical equation? Think about a chemical reaction, which is hydrogen reacts with oxygen to produce water. Okay, how do we write the chemical equation? We know the reaction is making the water. The chemical equation is hydrogen and oxygen are reacting. In a chemical equation, we write the reactant on the left-hand side. So we write hydrogen and oxygen. We've learned that hydrogen is a diatomic gas, so it's H2 plus, and oxygen also is a diatomic gas. So these two react, so we show what happens with an arrow that shows a chemical reaction, and the product is on the right hand side. So you must be familiar with the chemical equation, but we're still going to go through all of it. So this is how we show it. That's a chemical reaction. But you see that the chemical formula for water is H2O. It's not H2O2, and we cannot have different number of elements on either side of a chemical equations. So we have two hydrogen here and two oxygen, but on the other side we have two hydrogen but one oxygen, and that is not true. So we cannot have different number of elements. We cannot just use one of the oxygen and then we throw away the other oxygen. That cannot happen. So we should have the same number of elements on both sides. So let's take a look at this reaction in the next slide. So here is the actual balanced chemical equation to make water. Okay, as we said, hydrogen molecule is H2 react with oxygen molecule, which is O2, it's diatomic gas, to make H2O. You see the number of hydrogen and oxygen are equal on either side of the chemical equation. So actually this is the balanced chemical equation. 2H2 with oxygen O2 makes 2 water molecule H2O. This is balanced because we have the same number of hydrogen on either side. We have 4 hydrogen here and 4 hydrogen here, 2 oxygen and 2 oxygen here, so it's balanced. So in a chemical equation, we write the reactant on the left hand side and the product on the right hand side. We show the process of the reaction with the arrow, and there is one more thing that we're going to talk more about this in the next lecture slides, is the phase of the reaction. So we didn't show it in this reaction, but we do have the phase. For example, hydrogen, we know it's a gas, and so we show the phase like that. We have gas, solid, and liquid. We also, well, let me write the liquid again. Liquid. We also have aqueous solution, and we show it with AQ, and we put all of these in parentheses and in front of the element, after the elements. Okay, so hydrogen is a gas, oxygen is a gas, and water is a liquid, so the phase is liquid. We're going to talk more about this in the next lecture slides. So now that we know how to write a chemical equation, let's learn how to balance them. We can follow these easy 4 steps to balance an equation. As I said, most of you might have learned balancing a chemical equation in previous chemistry courses, but we're going to go through it together. So the first thing that is very important is to write the correct formulas. Okay, we've had a lecture on how to name the chemical compound. So when you hear the name of the chemical compound, you have to know the correct chemical formula for that compound, and that's a key step in writing a chemical equation. Okay, so you have to know the correct formula, and you write your chemical equation. One thing that you have to know is you should use coefficient in front of the formula to balance the chemical equation. Okay, you can never change the subscript. So subscripts are fixed, you cannot change that. So if you want to change a number of elements, you have to use coefficients. Okay, and in your chemical equation, you begin with the elements that appear only in one place. We will have some example in the next slides. If you have, for example, oxygen in two compounds on the reactants, do not touch oxygen yet. Okay, start with something else that is just in one compound. Try to balance that, and then we move forward and balance the other elements. And one more thing that you have to know, it's better to save the pure elements. Like if oxygen is as O2, I just come up with the oxygen, but it could be anything else. Okay, I'm just an example. So oxygen is just in O2, for example. So you should save that for the last step. Why do we do that? Because when you put a coefficient here, for example 2, you are only changing the number of oxygen. But for example, if you have LiO, if I put a coefficient here, when I change the number of oxygen, I also change the number of lithium. Okay, so that would change things in the chemical equation. But if you have a pure substance like that, it's very easy to deal with. So you can balance everything in the end. When you have different number of things, you can just use that to make everything fixed. Okay, so save the pure elements for the last step. Okay, let's have some examples. So our first chemical equation, so I have this habit of writing the elements under the arrow, and write how many of each you have on reactant side and the product side. So for potassium, we have one chlorine, and we have 3 oxygen. On the reactant side, we have 1 potassium, 1 chlorine, and 2 oxygen. Okay, so it seems like it's balanced for potassium and chlorine, but for oxygen it's not. So you have 3 oxygen in the reactant. In product side, you have 2. So in order to make this 3, you have to divide this by 2 and multiply it by 3. So if I have 3 half here, you multiply this by 3 and divide it by 2, that gives you 3 oxygen. Okay, so that makes it 3 and it's balanced. But you cannot have coefficients as ratios. Okay, so first you have to come up with the same number of elements on both sides when it's balanced, and when you end up with a ratio, you have to multiply the whole equations by the denominator in order to eliminate the denominator. So it's 2 here, so you multiply the whole equation by 2, so that makes it 2KClO3 gives you 2KCl plus 3O2. Okay, so if you check it, now you have 2 potassium, 2 chlorine, 2 times 3 is 6 oxygen, 3 times 2 is 6 oxygen, so it's balanced, and you don't have any coefficient in a ratio form. Okay, so let's see the other one. So we have carbon, you have 2 carbon, and you have 1 carbon here, so I write 2 here to make this 2. Oxygen is in 2 places, so we do not touch oxygen yet. It's better work with carbon and hydrogen first. Okay, so you have 6 hydrogen here on the reactant side, you have 2 here, so if I put 3, that makes this 6. Okay, So now I have balanced the carbon and hydrogen. So now it's better to go and check oxygen. I have 2 times 2 makes it 4 oxygen here and 3 oxygen here, so it's 4 plus 3. I have 7 oxygen on the reactant side. So I have on the product side. I have 2 oxygen on the reactant side. So in order to balance that, to make it 7, I multiply it by 7 divided by 2. So I have 7 oxygen here. But just like the previous example, we cannot have it in a ratio form, so you multiply the whole you multiply the whole reaction by 2 in order to eliminate the denominator for oxygen. So the balance equation is 2C2H6 plus 7 oxygen gives you 2, oh not 2, not 2, gives you 4 CO2 plus 6 H2O. Okay, that's the balanced chemical equation. So you have 2 times 2, 4 carbon, and you have 4 carbon here. For hydrogen, you have 2 times 6, you have 12, and here you have 6 times 2, you have 12. And oxygen, you have 14, and the reactant side 7 times 2, and in here you have 4 times 2, 8 plus 6 is 14, so you also have 14 on the reactant side, so it's balanced. Okay, our next example. So we have potassium hydroxide with phosphoric acid. So when you have a polyatomic ion, we've learned about polyatomic ion, okay? It's easier to balance the equation based on the whole ion instead of each element. It makes it simpler, okay? So what ions do we have? Especially in the ionic compound reaction that we're going to learn more about the precipitation reaction, acid-base reaction. We're going to learn more about these things. But in general, when we have polyatomic ions, so what ions do we have? You have potassium, you have hydroxide, so potassium plus hydroxide, you have H plus. So if you think about it, you have H here and you have OH here, but these are in 2 places. But this is a hydroxide ion. This is one of the polyatomic ions that we had in the table, and this H is H plus, and phosphoric acid, phosphate, so it's basically H plus and PO4 3 minus. So you have to memorize these things. You have to know the polyatomic ions, right? So we have H plus and PO4 3 minus, phosphate. Okay, so let's see how many of each we have on the reactant and product side. So potassium, we have 1 potassium, 1 hydroxide, we have 3. You have to be careful with this. This H, you have 3 here, 1 H here, but this H is for OH, so we already counted for that. So we have 1 hydroxide and 3 H, H plus, okay? So we have 3 H and we have 1 phosphate, okay? On the reactant side, we have 3, because we have these 3 subscript, it means we have 3 potassium ion. Hydroxide, where is hydroxide? It's in the first time you see it's hard to find the OH, but you have to know that water is H plus and OH minus, okay? That makes H2O. You have 2 H and 1 oxygen, H2O. That's how you make water, okay? It's a H plus ion and OH minus anion, okay, hydroxide anion. So in your water, you have 1 H and 1 OH. So 1 OH and 1 H in water, and you have 1 phosphate. Okay, so now let's balance this. So potassium, we have 1 in the reactant, 3 in product. So let's make this 3. Okay, so we make our potassium 3. We also make the hydroxide, because this coefficient goes for both of them, right? We also make the hydroxide 3. Okay. So potassium is okay. Hydroxide, we have 3 on the reactants, 1 in the product. Where is hydroxide in the product? It's in H2O, right? So if I put a 3 here, now I have 3 hydroxide. I also have 3 H plus. So this is also 3, okay? So it seems like I already balanced the H plus as well. So I have 3 H plus here and 3 H plus in the reactant, so it's balanced, and the phosphate is 1 and 1, so it's balanced, okay? So it seems like all the ions are balanced. You can also balance the equation with each element. That's still fine, but it just makes it longer and harder, okay? If you have a whole packet of ions that just repeats with the same structure as the same packet, it's easier to just balance the whole group together, okay? So the polyatomic ions are a group of elements that they're not going to change, okay? So the group is the group. So it's easier to balance the group on both sides, okay? So that's why we balance phosphate all together instead of balancing for phosphorus, for P, and for oxygen. You see, it makes it very hard because now oxygen is on all of these compounds. Oxygen is in the phosphate, oxygen is in hydroxide, and you have it on both sides, okay? That makes it harder to balance, okay? So whenever you have polyatomic ions, it's easier to balance the equation based on the ions instead of elements. And here we have our last example. So we have this reaction. We have the reaction of solid silicon dioxide. So let me change the color. Okay, so SiO2 reacts with solid carbon, and so it's solid. I write the phase as solid and solid. Reacts to produce solid silicon carbide, SiC, and carbon monoxide. So it's CO monoxide. It's a gas. Okay. So in order to balance them, carbon we have in 2 reactants, so we save it for last. Silicon we have 1 and 1, so it's balanced. Oxygen we have 2 in here, so we need to put 2 to balance it. We have 2 oxygen. And now we have carbon, so we have 2 in here and 1 in here, so make it 3. So we need 3 carbon in the reactants to be balanced, okay? So that's our last example. You need to go ahead and do end of the chapter practice problems to have more practice.